Welcome back, Physics 30. This is the third video, so I kind of left you with this one. And the thing is here, I could have done it the long way. I could have converted electron volts into joules and then figured it out using E equals hc over lambda by using the conversion 1 electron volt as a 1.602 times 10 to the, oh my goodness, minus 19 joules. But of course, using this equation here, it's a lot easier. We don't have to convert it. All right, so looking at this one. So E equals 1240 over lambda. So substituting this in, so this time 550 is the wavelength. So that is going to give us 2.25 EVs, electron volts. So 2.25, and so again, the total energy of the photon is going to be distributed to the work function, dislodging it, and anything left over is going to go here. So the energy of this wave, 2.25, and the work function was 2.28. Oh goodness, look at that. Look what's going to happen here, ladies and gentlemen. So if we take, if we solve for this, 2.28, oh my goodness, we get a negative number here, which we can't have. Negative 0.03 EV. So we can't have negative. And if we take a look here, total energy of photon and energy to dislodge electron. So we can't have that. Therefore, there is not enough energy to dislodge an electron. So we don't have enough. We require 2.28. We got 2.25. So nothing will happen. I will not have any electrons moving across that gap. All right. So again, this is a useful equation if we're talking about electron volts. And quite often we are doing that, talking about single electrons. And finally here, applications of the photoelectric effect. Where do you see this in real life? The photoelectron effect, besides playing an important historical role in confirming the photon theory of light, also has many practical applications. One of them is a burglar alarm, and automatic doors often make use of photocells or circuits seen earlier. When a person interrupts the beam of light, the sudden drop in current in the circuit activates a switch, often a solenoid, which operates a bell, opening a door. Or of course, garage door openers use this idea too. If you cut off the beam, then we don't have a current, and it causes your door, or prevents your door from closing on whatever that object is in the way. UV or IR light is sometimes used in burglar alarms because of its invisibility. Many smoke detectors also use this to detect tiny amounts of smoke that interrupts the flow of light. So we can think of it as smoke detector. We have a constant amount of, that's why the batteries go dead eventually, right? Because you have a constant amount of current flowing across here. But if I have little smoke particles coming in here blocking this, then it registers in terms of, oh, there's no more current, let's set off the alarm. So it kind of works in reverse. So if the flow of light is disrupted, then something happens. For applications today, the vacuum tube photocell that I just showed you has been replaced. So it's often replaced with a semiconductor device known as a photodiode. In these semiconductors, the absorption of a photon liberates a bound electron so it can move freely, which changes the conductivity of the material and the current through a photodiode, and it becomes altered. All right, so you should have no problem with the assignment. A lot of it involves applications of the largest kinetic, the maximum kinetic energy, the threshold energy, and a few calculations going with that. Key thing to note is if you're dealing with joules, You can use just simply this when you're figuring out energy using this, but again, your lambda has to be in meters to get that energy, and then you can figure out this equation here. But if you're given electron volts, then we use this simplified equation, which I didn't go over the derivation, but basically you're just converting it from units of joules to units of electron volts. All right, so you should be able to do that, and we'll see you again.